Ever found yourself confidently simplifying a complex circuit to a neat Thevenin equivalent, only to hit a snag when those tricky dependent sources appear? Calculating the Thevenin resistance, or Rth, often feels straightforward with independent sources. But what happens when the voltage or current of a source inside your circuit depends on another parameter within that very same circuit? When faced with dependent sources, you absolutely cannot simply turn them off to find the Thevenin resistance. Instead, the most reliable and accurate approach is to use the test source method. This involves applying either a test voltage source or a test current source across the terminals where you want to find Thevenin, and then calculating the ratio of that test source to the resulting current or voltage. The reason this special method is necessary is that dependent sources are not truly independent components. Their output is dictated by a voltage or current elsewhere in the circuit. If you were to simply treat them like independent sources and set their values to zero, you would fundamentally alter the circuit's inherent behavior. These sources are active components that contribute to the internal resistance of the network, and they continue to respond even when independent sources are deactivated. Therefore, we must apply an external stimulus to reveal this internal impedance. To practically apply this, first, turn off all independent voltage sources by replacing them with short circuits and all independent current sources by replacing them with open circuits. Leave the dependent sources untouched. Next, connect either a 1-volt test voltage source or a 1-ampere test current source across the terminals where you need Thevenin. If you use a test voltage source, calculate the current it supplies into the circuit. If you use a test current source, determine the voltage that appears across its terminals. Finally, Thevenin is simply the ratio of the test voltage to the current it draws, or the test current to the voltage it produces. This elegant test source technique is especially powerful because it inherently captures the dynamic interaction of dependent sources with the circuit. It is a fundamental concept for understanding the true output impedance of complex active circuits, such as those found in amplifier stages. Mastering this method ensures you correctly model the behavior of active devices in circuits, a crucial skill for any serious electrical engineer. This approach is not just a trick. It is a direct application of Ohm's law to the output port of an active network. By consistently applying the test source method, you gain a robust way to characterize any linear circuit, regardless of its complexity or the presence of these reactive dependent elements. This allows you to accurately predict how your circuit will interface with external loads, ensuring stability and correct operation. It is the key to unlocking the predictable behavior of circuits that contain those vital dependent sources, making your analysis both precise and insightful.